Hello, we're going to continue on with SQL. So we'll talk about different types of joins today. So we already know the two different types of joins that we talked about in relational algebra. So the first one was Cartesian product, which is pretty much all the possible combinations between the two tables that we're joining. We also talked about natural join. So we're joining two or more tables where the common attributes they have the same value, they're equal to each other. We also talked about inner join and outer join, and we'll talk about that in SQL. So let's just go back to the first join that we talked about, which is Cartesian product. This is a cross join in which it returns all of the rows and all the tables listed. So if you were not specifying any kind of condition in the where clause, this wouldn't be really useful. So we have an example table called movies, which has movie title, director ID, and release date. People has person's first name, their last name, and then there's a person ID. The query here using Cartesian product is select movie title. We want to return the first and last name of the person. We're joining movies and people, these two tables. Okay, so here we have title of director's ID. This director is a person, obviously, so this ID should actually be, there should be a person ID that matches the director's ID. So from movies and people, so we're joining these two tables. If we didn't have this where clause, then it would be just returning every single row and every combination with this every single row from people. But here we are indicating here that where the director ID is equal to person ID. So this is going to be returning the movie title as well as the director's first name and the director's last name. You can also do it self-join. So when you do self-join, it means you're taking a Cartesian product of the same exact table. Okay, so if, for example, we want to find two different people living in the same state. Okay, so we have this schema person, which has their first and last name, their ID, their state and city which they live in. Okay, so these are going to be two different instances of people, so the two different persons. So we know that we're going to be joining person and person. And when we do this Cartesian product between person and person, since they have the same name, we want to differentiate the two. So we want to rename them to be something else. So here we have person as P1, and again, as is optional. So you could do person as P1, or you can simply just do person space P1, comma, person P2. We wanted to find two different people living in the same state. So we want to print out the first person's first and last name and the second person's first and last name and the city that they both live in. So I'm going to have P1 that person first name and then P1 that their last name, P2 first name, P2 last name, as well as the person's state. So this could have been P1 or this could have been P2 because they live in the same state, they will have the same value. Okay, we're taking a Cartesian product between person and person. We have renamed them to be called P1 and P2. Okay, now the where clause, we want to make sure that P1 and P2 live in the same state. So P1.state should equal P2.state. But we want to make sure that these are two actual individuals. They're two different people, not the same person. So their person ID should be different. We could have made sure that their first name and then the last name are different, but it is possible that there are more than two people with the same exact name that live in the same state. So person ID is unique. The first and last name are not unique. They're not keys, right? So this is a primary key. So we are setting P1.person ID is not equal to P2.person ID. So we can also do natural join. So here we want to list the names of instructors along with the course ID and then the courses they have taught. So select name, so this is the name of the instructor, and then the course ID from student and then takes, where the ID of the student is equal to the takes of the ID from the takes table. So the same thing could be done using select name and course ID where, actually from student natural join takes. So this is only possible because the ID attribute is the same name, so ID appears in student as well as takes. If this had been student.sid and then text ID, then this wouldn't work. but this natural join works because these attributes have the exact same name. Okay, so you can have more than 2 tables or 3. There's really no limit on how many you can do. You could do R1 natural join R2, natural join R3. So there's really no limit. Here's an example of student which has their ID, their last name, department name, and total credits. We also have takes, which this particular student, this is the ID of the student, has taken this particular course, and they took this section during this semester, this year, and then this is the grade they received. Okay, so if you were to take a natural join between student and takes, it's only going to return, for example, if you're looking at the first row on this last name saying ID 00128, it's going to see if there's a matching ID in this takes table, and we can see that these first 2 rows are actually a match, so it'll return this row with this course ID, section, semester, year, and grade, and it's also going to return this ID saying computer science 102 with this course ID, section, semester, year, and grade. So natural join is very useful, and we kind of tend to overuse it. We just use this type of join just because it's easy. But there could be it could be dangerous. It could be incorrect. So here we're looking for the list of names of students along with the title of courses they have taken. So the correct version here, so we're looking at 3 tables here, not 2. We have student, takes, course. So this ID is the ID of the student, and then this course ID is this course ID. They're the same. Okay, we have the department name of the student here, and then this department is the course which it's offered. So if it's CSC 5720, then this will be computer science department. Okay. So here we have select name and title from, and then we are taking a natural join. We're joining the 2 tables, student and takes. Okay, so this will return the ID of the student as well as all the courses that they have taken. And then whatever we got as a result, we're going to take that and Cartesian product that between the course where the course IDs are the same. Okay, so the course IDs are the same. So how come we didn't take a natural join between student, natural join takes, natural join course? It just seems like an easier way to do it, right? But because of this attribute department name, okay, so this would actually omit all the students that has taken a course other than their actual department. So let's say there's a student whose major is computer science, but if they took a course in biology, because of this, it would not be returned because it's going to set department name of student and course to be equal to each other, which is not what we meant to do, right? So because of that, pay attention to all of the attributes. Okay? So this will be the right version. You can also do a natural join using with clause in the using clause. So here we have select name and title from, and then we are doing a student natural join takes, so which is what we did here, right? And then we try to do that with natural join course. That would be fine if they're only looking at these common course IDs, but we don't want this department name to be set to equal to each other because that's not what we're meant to do. So we can do join course using course ID. So by doing so, this department name, these will not be set equal to each other. It's only going to set course IDs from takes and course equal to each other. So you can do join course and then this keyword using and then course. Okay, you can also use on condition. Okay, so it's a keyword as well. Okay, so we have select asterisk, which means select everything from student join takes on student underscore ID is equal to takes that ID. So it's going to join these 2 tables on this condition where the student ID value is equal to takes ID. Okay, so this is the same thing as select everything from, and you do a Cartesian product between student and takes where you have this condition. Okay, so there are many ways of doing the same exact query, just different syntax, different ways of doing it. Okay, let's talk about different outer joins. Okay. So this computes the join and then adds tuples from one relation that does not match the tuples in the other relation. So this one does, you could have null values. So there are three different types of outer joins: left outer join, right outer join, and then full outer join. Okay, so here we have a relation course, and then we have a prereq. This has course ID, the title, department name, and credits of that course. Prereq has the course ID and then the prereq if there is any. So Bio 301 has a prereq, and it's going to be called 101. And not every course will have a prereq, right? So here, course information is missing CSC 437. Okay, so that is missing. I think they meant to say 347. 347 is missing here, right? Okay, and then this prereq is missing CS 315. Okay, so CS 315 appears in this course, but I guess it doesn't have a prereq, so it doesn't appear in this table. Okay, so with that in mind, let's go over the first outer join, which is called left outer join. Okay, so here the order does matter. Whether it appears on the left-hand side or the right-hand side, it does make a difference. If I was using this symbol, this left outer join symbol, and I had switched it to be called prereq left outer join course, it would actually not give you the same results. Okay, so you can take a look at here. So it's going to be all of the rows will be returned from whatever appears on the left-hand side. In this case, it'll be course. Okay, so we have course, this is the course, and then this is the prereq. Okay, and we're doing a course and then prereq. Okay, so this means that every single row from this course will be returned. Okay, so it may not have a matching value in the prereq, but it'll still be returned. So we have Bio 301 as the first row, CS 190, CS 315 all appear, right? Okay, but CSC 347 does not appear here, so it's only going to be taking all the rows from the first table, or the left-hand side table, which is course. Okay, and if there's a match for prereq, that'll be listed here as well. So Bio 301, you can see that, and the prereq for that is Bio 101, so we're going to put that here. Okay, CS 190, we can find that here. The prereq for that is CS 101, so that's listed here. Okay, CS 315 does not appear here, so we don't have a value for prereq, so we're going to just write null. So right outer join does the exact opposite. It's going to return all of the rows from the right-hand side. Okay. So here we're going to only list the rows from prereq, which is the right-hand side. So Bio 301, CS 190, and then CS 314, 47 were listed here. Okay, so Bio 301 is listed here, so we're able to get the title, department name, and credits here with the prereq. Okay, CSC 190 is game design, computer science, and 4, so those are all listed here. CS 347 is not listed here, so there's no value for title, department name, or credits, so we're going to leave them to be called null since it's unknown, that value is missing. Okay, and full outer join is both, right? So it's going to return every single row from both tables. Whether there's a matching or not, it's still going to be listed. So Bio 301 and CS 190 are in both, so those will be listed. CS 315 is not here, but it'll still be listed. CS 347 is not in this table, but it'll still be listed. It's just that if there's no matching, which were these last two rows, it'll just have null for those unknown values. And this is a symbol that you use, so it's kind of like natural join, but if it's left outer join, it's going to have a little opening pointing to the left-hand side. If it's right outer join, it's going to be pointing kind of to the right-hand side. And if it's full outer join, it's going to have that on both ends. Here we also have inner join. So this inner join joins two tables, and it's based on the on clause. So we have course, inner join, prereq, on, and it's only going to return the ones where and this condition is met. So course.course ID is equal to prereq.course ID. Okay. So what is the difference between this one and natural join? Okay. Course left outer join and then prereq, on course ID and then prereq.course ID. Okay, so this will return only the ones, and then we're specifying this condition here, right? Where course.course ID is equal to prereq that course ID. Okay? So the ones that they had in common, these two tables were Bio 301 and then CSE 190. So only these two will be returned. And then left outer join, we just went over that. Left outer join will return the one. All the rows from course will be returned, whether there is a match prereq or not. So this last row, even though this doesn't appear in the prereq table, it will still be returned. Okay, so here's another example of inner join. So we have a person which has the first and last name, person ID, state and city, movie which we have the title, director ID, and studio ID. The query here is that we are selecting the title of the movie and then the first and last name from movies, inner join, person on, and then the director ID is equal to person ID. Okay, so inner join means what? Okay, we're only going to be returning the ones where this condition is met, right? There's another query that says select title, first name, last name from movies inner join person on director ID is equal to person ID. Okay, and then you can also add a condition here in the where clause where the studio ID is equal to 1. So this is just one extra thing that we added here. So from here, it's only going to return the ones where this has the value 1. Okay, we can also join more than 2 tables. So here we are joining 3 tables, and because we are going to be mentioning these a lot, instead of having, movies, that movie title, movies, that studio name, studio, that studio city, just to make it short, they did a rename operator, movies SM, person SP, studio SS. Okay, so this is optional, but if you have a long query and you're going to be mentioning these tables a lot, this is a good idea to just kind of save you some writing and some time. Okay, so we're joining these 3 tables where the director ID and then the person ID from movie and person are equal to each other, and movie, that director ID is equal to P dot person ID. I think that is actually the same thing, so I don't know why there's a duplicate here. Okay, so that can just be removed. The second one has movies, that movie title, movies, that studio ID, person, that person. So as you can see, you're having to write the word movies, actually spell out the whole name of the relations, movies, person, another person here, studio. So that's why it's just a good idea to just kind of use this rename operator for short. And in here we have people inner join, and then movies join, and then we have another parentheses. This is an inner join. We're joining movies inner join studios based on the common studio ID between the studio and movie, and then movie direct ID is equal to person ID, and with that we're joining that with people. Okay, so you can have more than 2 tables when you do a join. There's really no limit on how many tables you can join. Okay, so let's take a look at these examples. We are continuing on with the examples that we went over. It was sailors. So the sailor's ID, sailor's name, sailor's rating and age, boat, boat ID, boat name, color of the boat, R. So the sailor has reserved this boat ID on this date. So find the names of sailors who have reserved all boats. So this keyword all, I kind of bolded this one because I don't know if you remember, but whenever you see the keyword all, it was a combination of 2 things, right? Okay. So with that in mind, you might have to go back to the previous lecture and then take a look at some examples of this. Number 7, find the names of sailors who have reserved all boats. So same thing as number 6, but here we have this condition whose name starts with typing. So go ahead and pause this and work on these 2 queries. You should be taking between 8 to 10 minutes for these 2, and then once you're done, hit play. Okay, so let's go over it. So whenever you see the keyword all, it was going to be a combination of not exist, a subquery, except a subquery, right? So find the names of sailors. Okay, so we're looking for sailor's name, which is going to be in the S table. So select S.S name from this table, which is S, where not exist. So this, just to jog your memory, not exist will return, we want this to be empty. Okay, not exist means it will return true if it's empty. So the parentheses following not exist, we want this to be empty. So whatever was returned here, and then we're going to subtract whatever was returned here, we want that to be empty. Okay, so the first subquery is going to return the list of all of the boat IDs, the list of all the boat IDs, and then we have an except, and then these are going to be the list of all the boats that this particular sailor, S.SID, has reserved, which can be found in the reserve, R.SID. Okay, so these are a list of all the boats, and these are the list of all the boats that this sailor has reserved, right? So let's say we have 3 boats in inventory. We have B1, B2, B3, and then the sailor has reserved B1, B2. This will return B3 because B3 will not be able to be subtracted from this, right? But if they reserved all 3 boats, B1, B2, B3, so we take from here we have B1, B2, B3, and then except B1, B2, B3, this will be empty, right? This, which is what we want. Then that sailor's name will be output. Okay, number 7 was the same, except we have the name condition where the name starts with typhoon. Okay, so this one we're adding the name condition in this first subquery where select boat ID from B where the boat name is like, and then we have typhoon, and then we have this percentage, meaning it's gonna start with typhoon and may or may not have anything following that because this can have anywhere from 0 to many characters, right? So this will return the list of all of the boats that starts with typhoon, and if the sailor has reserved all of those boats, then this will return empty, which is not exist, right? So then their name will be returned. Okay, number 8, we have find the sailors' IDs of sailors whose rating is better than some sailor called Bob. So let's say there are five sailors called Bob. As long as this person's sailor ID or their rating is better than at least one Bob, then they will be returned. Number 9, it's the same, but here it's every. So as long as this, the sailor's rating has to be greater than the 5 Bobs that we find from our image. Okay, so let's take a few minutes for each query, and then once you're done with it, you can go ahead and hit play to compare what you got and what I got. So if you feel like your answer is different than mine, but it's still right, always feel free to message me in Discord. You can always email me, and I can take a look at your query to see how what if it's right or if it's wrong or what you can do to improve. Okay, so we are looking for sailor ID, so it's going to be S1.SID. And since you're looking at 2 different instances of sailor, the sailor that we do want to return, and then another sailor that are going to be called Bobs. So I have S as S1, S as S2. So I'm doing a Cartesian product or self-join. And whenever I do that, I want to rename it, right? So S as S1, comma, Cartesian product, S as S2. Sailor IDs of these 2 are different, meaning we were dealing with 2 different people. Okay, S1 dot rating is greater than S2 dot rating, right? Because we want the sailor to have a better rating than some sailor called Bob, which is S2. Okay, and S2's name is going to be Bob. So this is one way of doing it. You can also do it this way. So select SID from S where the sailor's rating is greater than, and then we have a sum, and in parentheses, we have a list of all the ratings from a sailor named Bob. So this will have 5 different values. If there are 5 Bobs, it's gonna just have, this table will have 5 different numbers, assuming that the rating is in numbers. Okay, so this will also return just 5 numbers, and so if this rating is greater than at least one of these ratings, then it will be returned. For this one, this rating has to be greater than every single rating that was returned from the subquery. Okay, so make sure you know the difference between some and every. And then the last 2, number 10, find the sailor IDs of sailors with the highest rating. And number 11, find the name and age of the oldest sailor. So this can be a little bit confusing. You might have to go back and take a look at some of the SQL queries examples that we went over. And there could also be more than one way of solving these queries. Okay, so take about 8 to 10 minutes for these queries, and once you're done, hit play again. Okay, so find the sailors' IDs of sailors with the highest rating. So we're looking for SID from S, and we're going to rename it to be called S1, where this person that we're looking for's rating is greater than or equal to all, and then we have a parentheses which returns the list of everyone's rating, all the sailors' ratings. So if their rating is greater than or equal to everyone's rating, then they have the highest, right? Okay, so this is how you deal with the highest rating. Okay, and then here we want to find the name and age of the oldest. Okay, so it's very similar to the first one, where you're doing s1.name, and then we also want to know their age, since they will be the oldest. Here from SSS1, where their age is greater than all. So this subquery will return a list of everyone's age, all the sailors' age. So if this person's age is greater than or equal to all of them, then they are the oldest. So we're going to be outputting their name as well as the age. Okay, so it might be tempting for you guys to, use the max function, and that's great. I mean, you can use that max function, but you want to use it right. So let's take a look at this first one. It says select s1.sname, there's the sailor's name, and then max of s1.age from ss1. Okay, so this is illegal in SQL. Later, when we talk about installing SQL, MySQL, and actually running these queries, this will actually give an error, right? So the select clause uses aggregate operations. Okay, so these are aggregate functions, right? Max is an aggregate function. So this has to be only using aggregate operators. So you're actually not able to output a name. So what happens if there's more than, one sailor that has a max age? What if, the max age was 99 and then there were 3 sailors, right? So then whose name is outputted, right? So whenever you're using an aggregate function such as max or min or count, that's going to be the only thing you can have in the select clause. Okay? One exception is that you can output something if you group by this one. So if you're grouping by S name, then you could do it too. Okay, but in this case, we don't have group by, so the only thing you could output is max age. So if you wanted to know the name and age of the oldest sailor, this would not work. If you're only interested in age of the oldest sailor, then you could simply just remove this and then output the age, then that one is allowed. Okay? So here is how I would do it. So select s1.sname, s1.age from S1, where this person's age is equal to, and then this s2, okay, from SS2. So this subquery is going to return a single number, which is the max age. So this actually should be returning 99. Okay, so if S1's age is equal to the max age, then we can output. Okay, so we're not using max function here, so we are able to output S name as well as age.